All right, everyone, it's now 2:30, so we can get started. Welcome back to another lecture of Com 290. This is lecture 13. Very excited to have you all here today and hope your week has been going well. So there are a few announcements that we'll get started with. First off, the assignment 8, GPT prompt engineering for developers, that is due this Friday. A few people have already done it. It's looking very good. So when you complete this assignment, do note that you'll actually earn a certificate from the Deep Learning AI Academy, and that'll be also a pretty cool thing that you might be able to show off. And it's something, I also completed this a few weeks ago, and I think that it does serve as a very good introduction for learning how to write good prompts, and also a good introduction on how to use the ChatGPT API if you ever wanted to make your own AI apps. So this will be a good thing to look at. And now also, again, we are nearing the end of the semester. So there are 2 more lectures for Com 290, including this one, which is really exciting. Next week, just as a reminder, is Thanksgiving break, I believe, on Wednesday, so there'll be no class. There will be a lecture, though, on the Wednesday, the final Wednesday. So that is the last day of class. It should not take the whole time. It's going to be rather brief, but we will be meeting here as scheduled. And then also, again, just be on the lookout. I don't think they've gone out yet because I haven't gotten any email about this myself. But be on the lookout for the UNC course evaluations. This will come from the university officially. And please fill this out if you have the chance. It'll help us immensely, including if we are to teach 290 again. So we look out for that if it comes out this week or next week. It might come out near the end of next week, but good thing to look out for. And then again, so the getting started tutorial progress check has passed. I think I already went through, and for all the people who completed it, they got the 1 point on Gradescope. I think I deleted this on Canvas though, because it will not be part of the overall grade. By this point, since we are nearing, we're only around, where are we now? I think we have like seven academic days left, maybe 7 or 8 before the end of the semester. So this would be a good time to at least have made it past halfway on the Getting Started tutorial. That way you don't have to spend a lot of time on the last week and Thanksgiving break working on it. Of course, as a reminder, the Getting Started tutorial and project plan, both parts of the final project, will be due on the last day of class at 11:59, and they are open on Gradescope. And then also, unfortunately, details, we have not added a doc here, but I plan on sending that out for the presentations. That'll happen, unfortunately, again, very sorry about this, 8 a.m. on the Friday. That is the final exam time that the university has assigned to us. So we will all be meeting there. And once the doc has been written, it will be sent out on Canvas. But the submissions for everything that is needed up until this point is open. And so you can finish it early if you want, and then be done for the rest of the semester. All right. Any questions there? All right. And then again, just the same 2 announcements last time. Unfortunately, I think there's another one that KMP sent out, but I forgot to add it. Something about some hot chocolate event. So I would be on the lookout for that. But again, just in case you either missed it or you are still thinking about your summer plans, the study abroad applications have opened for the summer, and there's 2 great classes offered by Professor McMahon. She's amazing. This will be a very good opportunity. So there's Com 380, which is I forget the exact title of the course. I think Technology, Ethics, and Culture, if I remember correctly. That particular course is a great one because it fulfills a good Gen Ed, and also it is required for the data science minor. Well, it's one of the requirements, so that will be a good course. And so CC will be offering that, and she'll be offering the main course that she usually teaches, Comp 311. And looking out, since many of you might be 210 students right now, you will likely be taking her Comp 211 next semester, if you're in 210 right now. So this would be a very natural continuation to take 311 with her in the summer in Copenhagen in Denmark. So that would be a lot of fun. You can go to this link right here to learn more about the program. And then also, again, Pearl Hacks registration is open, so if you're interested in attending this event in February, registration is available. So it would be a great opportunity if you either attended HackNC or you have, you're looking to attend your first event. This one might be good. And they always do a very good job running this. There are a lot of opportunities. Mainly this particular hackathon is of course geared for women, non-binary students, etc. But it is a great, if you do fall into that category, it's a great opportunity to meet people and to learn more. And also there should be other, if you are not in that category, I think there's also volunteering opportunities too. So if you'd like to volunteer, I'm sure they would find that or be grateful for that. And with that, it is now time, I'll hand it off to Noah to talk a little bit about build systems.
Alrighty, thanks Ajay. Okay, so today we're going to be going over build systems and GitHub Actions. Just before we get started, does anyone have sort of a loose definition? Who here feels like they could define what a build system is, just by show of hands? Okay, that's good. That's great. I was hoping no one was too familiar with this. But okay, so we'll just hop into it. So build system, sort of a loose definition of it, is just any set of tools or programs that we use to take code and automatically transform it in some way. And I know that sounds really high level, kind of nebulous. Well, we'll give some more concrete examples here. But this can range from something like compiling code, like in C or Java. So if you're going through 2.10 right now, oftentimes in IntelliJ you can even just hit the play button. You don't really have to think about it. But what's actually happening under the hood there is there's a build step where your Java is being compiled to special code to run on your computer because your computer can't run straight Java. And this can even be something like, and so that's very low level. It can range from that to even something very high level, like creating a full Docker container to host a website or other service. And if you'll recall, Docker containers were something we covered early on, just an easy way to sort of bundle up apps and send them out. And so the purpose of build systems, why do we have those? We don't need a system necessarily to automatically do this every time, right? We could manually tell our computer, like, this is how you need to compile these files. This is exactly how you need to build this Docker container. And you can do that by hand, right? You can manually every time run the command like docker build dot. You can manually run the command, Java C for Java compile. But it gets very tedious and repetitive. And it's very hard, especially once you start scaling up to projects with many files, to know exactly which files you need to compile, which ones need to be included, which ones should be excluded, where they need to go. It gets really annoying, really repetitive. So as lazy programmers, we'd like to automate as much of that work as possible. And so we come up with this idea of build systems. So instead of us having to have to manually run these commands every time to, include this file, build this Docker container, do whatever, we do it all one time. We make a build system, and the build system automatically takes care of this for us. So we have something as simple as, clicking a button in Java or in IntelliJ, or clicking a button in VS Code, and that takes care of all of the underlying stuff. And so what you'll notice is there is no sort of one single build system for everything, right? There's a special tool for every use case, so there's different build systems for different use cases. And these are ones that you might be familiar with, you might not have seen yet, but these are really common ones that you'll probably encounter in your classes here, which is why I wanted to especially include make. In 2.11 you might see this, in 5.30 you'll certainly see this, but this is basically a way of automatically building projects, often in C, C++. If you've seen Gradle or Maven, Maven is, I believe, used still in 3.01, so that is how, have you guys, is anyone here in 3.01? I guess, we overlap with that class a little bit, so no one's, okay. But this is just another build tool that's used in that class. Xcode, if you're doing iOS or any sort of Apple development, not only is it the IDE itself, where your integrated development environment, where you're typing your code and testing, but there are special CLI tools, command line interface tools, that are specifically only for building your iOS and macOS apps. And that's their sole purpose, is to take your code, transform it into an app that you can install. And increasingly, we're even seeing sort of custom scripts take hold, where maybe one of these solutions doesn't exactly fit your use case. Custom scripts are a big thing sort of in the world of web applications. You'll see them a lot there. And that sort of is just something where it's like, my use case doesn't quite fit these, or maybe it's, small enough scale that it doesn't make sense to go for one of these sort of bigger options that just takes a lot to configure. So I've created my own script to basically take my code, build it, somehow transform it, and then create an output. And if you think about this, these are actually really, really important in terms of getting programs to anybody else who's going to use them that's not usually like a computer scientist. Because if you think about it, when you download Chrome, if you download an app, what are you doing? You're just hitting a button, it installs, and it works. But if we didn't have build systems, if we didn't have a way to nicely automate the sort of making of this one thing that you could just install, you're going to have to go to the Git or the Chrome like source code or the app source code, and you're going to have to build it from scratch, and it's a whole process. You can't do that if you're not like very technically inclined. So these are sort of the key step that bridge just your code that you've written that you're able to run on your computer into a nice like executable is usually what it's called, like a nice file that can then be executed or run on another computer. So it's how you take your programs, and turn them into something that you can then send to other people and have them run. And I actually want to take a quick second here to just sort of a quick little demonstration of these custom scripts here is even in a project that I started working on just the other day. This is a web app. There's a lot of configuration files here, but the one we want to look at here is package.json, which for this specifically contains our build script. And if we look at that, I'll actually blow that up a little bit. Okay, well, it doesn't want to blow up, I guess. Okay, a little bit. Okay. This is the build script right here, and it's just called next build. And next, you notice, was not one of those things that I'd covered here. It's not, next is not make, it's not Gradle, it's not Xcode. Next is actually, you might find, if you explore this yourself, it's a specific package just for making like web apps, that's it. And instead of them opting for any of these build systems, they said, we're just gonna use our own custom scripts to build because it just makes more sense that way. So this is actually a really custom, or probably common one that you'll encounter if you go down web dev, but that's all just to say there's a ton of different ways to build things and create your own build systems. So if we try and see how build systems integrate into sort of a bigger picture here. Build systems, as their name implies, only build something from our code, right? They only take something and then transform it into some sort of executable. But sometimes, or oftentimes, we also want to test our code and deploy it. So testing, if you recall, like the Pi test that we went over a few lectures ago, or unit test, is just a way to make sure our code behaves predictably. And then to deploy our code means, okay, I just made like, an executable. I just made some sort of calculator app or some sort of web app. But now I want to deploy it and put it somewhere where people can access it. And deploy just means send it somewhere so that it's accessible from a new location. So what that can mean for web apps is deploying it to a certain URL or website, like a link. If it's like a game or something or some sort of program you have to run on a computer, it can mean just uploading it to like some URL so people can download it. So when Chrome, for example, when Google makes a new build of Chrome, they deploy it and now it's reachable when you go to like google.com/Chrome, you can download it there. And that's all that means. So you can sort of think of it as a bit of a three-stage pipeline where typically you'll get some sort of thing where you want to test your code first. If that's all good, you then want to build your code, and then once that completes, you want to then deploy it. And occasionally you'll have actually some testing that happens between build and deploy just to make sure nothing went wrong in your build step, because if you keep in mind, build is transforming your code in some way, so maybe there's some sort of bug, some sort of error that happens, and that actually causes your built code to not behave as expected. So really verbose systems will test, build, test again, and then deploy. And if we sort of try and relate this back to class concepts, like I said, we can test our code with something like PyTest. We can build our code into an executable for others to run on their machines, and this is the exact step that build systems take care of. And then we can deploy that executable by like uploading it to a server or something like that, putting it on a website so people can view it. And these are sort of three distinct steps that you'll see. And I also want to take this second to mention how this can seem very just software oriented. So like, this is a bit of a day in the life of a software engineer, right? This is a very common thing in that practice. But even outside of that, you're going to see build systems are really integral. In cybersecurity, for example, does anyone remember the CrowdStrike outage from a few months ago, where like all the computers just went blue? It was a huge pain all over the world. That was actually caused because CrowdStrike in their system of building code and automatically deploying it, they had a bug where they did not check something after they built it, and it sent out faulty data to all those computers, and then those computers tried to read that and were crashing because they could not read that data. So even though, totally not even a bit software engineering adjacent, but more security focused, we still need these sort of pipelines to be very clear on what we're doing, just making sure code runs predictably no matter what setting that is. And I'm sure for other things like game dev as well, I'm not as familiar with that field, but there are still you need a step to go from your Unity project into a single sort of thing that you can upload to Steam to sell your game, or just to send a friend so they can play it. So this really touches sort of any area of computer science that you'll see. You always need some sort of build system. Does that make sense? Does anyone have quick questions on build systems specifically, how they fit into this flow? How's everyone feel with that? Could I get a thumbs up, thumbs middle, thumbs down? Okay, cool. So that's build systems, but this lecture is called Build Systems and GitHub Actions. So we have an idea what build systems are now. Let's see what GitHub Actions are. So GitHub Actions are a specific feature of GitHub, right? Not Git. These are totally separate things. These are a special feature of GitHub, the website. And what these let us do is they let us run specific tasks on our code, which again sounds very high level. We'll give concrete examples of that. Oftentimes these are triggered by pushing code to a branch. So you could think, every time you git push origin main, every time you push your code to any branch on GitHub, you can have it trigger an action. So you can think of that as sort of code waiting to be run. You push, that code gets run. Commonly, this is used by build systems to automatically build any code that you write. So what I mean is, if you have a build system like Make or a custom build system or something, oftentimes you sort of want that to run when your code gets updated, right? And it'd be very ideal if you could have that done automatically. So you've written some code, it's time to upload it, you push it to GitHub. Now, the ideal scenario is a build system automatically takes that code and will build some sort of executable that can then, be deployed or executed or tested. So GitHub Actions are commonly used, are very strongly intertwined with build systems. And another key thing here is that this actually all happens on GitHub servers, not on our machines, which is really nice because sometimes, if we have really big projects that we have to build or something, it can take a while on just a single laptop. But these happen on much more powerful servers that GitHub has, so we don't have to worry about that. And the terminology here that we're going to encounter this again. But basically, GitHub Actions are comprised at their core of actions or scripts. And this is just a specific task that is run on our code. And so an action is sort of a pre-made script. A script could just be, a script could also just be like a Python file that we have in our project that we want to run to sort of transform other files in our project. A job is just a list of actions to be taken, and then a workflow is just a list of jobs to run. So it sort of goes actions or scripts, jobs, and workflows. So I know that was a lot, but putting it all together, essentially GitHub Actions, if you just have to think about it one way, is a way for us to automatically perform actions on our code when it's pushed to GitHub. And oftentimes that action involves some level of building our code. Does that make sense to everyone? Any questions on specifics of GitHub Actions here? Okay, cool. And yeah, here, once again, we're just rehashing the terminology. And if you want a visual representation of what happens, this is sort of all of it built together here. So when we'd have some sort of event, like you get pushed to your repository, then that triggers this workflow. It starts right here, goes to your first job, runs the first action or script all the way down. That job completes, it goes to the next job. So it's very linear. You don't really have to worry about too much like out of order stuff. Just as you have it in your file, it will execute. And so to bring that all together, the plan for today is this. We will be using a custom Python script to build our code. So I know I just touched on certain build systems that are really big, but like I said, sometimes we have use cases that are so small, it actually makes more sense to just use a custom script. So that's what we're going to do. And in this case, our code is going to be a really basic website. So some HTML, really, really simple stuff. Even if you don't know that, don't worry. It should be, it's like I think 20 lines, so you'll be able to see it, and we'll step through that as well. And then past that build step, we are going to use GitHub Pages to deploy our code. And what this means is that our website is just going to be deployed to a special GitHub URL. So after we run this step, it's going to spit out a special link. And then if we click on that, we can see the code that just got built, or in this case, our website. And in general, deployment can be much more complicated. Today, we're just going to keep it really simple to deploying to a page because I want to focus more on the build system and GitHub Actions as a whole. But just keep in mind, the whole of GitHub Actions is really just, it can do whatever you tell it to do. So anything you need done for deployment, you can tell it to do. Anything you need to build your code, you can tell it to do. Because it's basically just another computer somewhere that's running a script that you tell it to run. But today, we're just going to keep it sort of low level here. And how we're going to set this up for our class, we're going to use a single GitHub workflow, which is going to contain 2 jobs and 4 actions/scripts across all those jobs. So if we look at this, we're going to have one workflow, 2 jobs, and then within those jobs across all of them, we're going to have 4 total actions and scripts. And we'll see those, we'll actually write those out. But that's the game plan for today. So does anyone, before we get into that, because the next thing is the demo itself, does anyone have any questions on what's going to happen, how these sort of fit together, how GitHub Actions work with build systems? Like that? Okay, cool. Then we'll hop into this. If you guys all hop on and try and get this link, I'll actually send it out right now in a Canvas announcement to make it easy. But instead of cloning it, actually, make sure you read these instructions here. First, click the fork button in the upper right on the repository so you get your own copy. And then click the green code button, but instead of local, switch to the tab that says code spaces, and then hit the big green create code space on main button. And we'll take a second to do this. Let us know if anything's going wrong. Ajay and I will go around to double check them. And if anyone's not sure on steps, we're about to do it here. So you can just look up here. First, you're going to want to come up to this right area, click this fork button. Just hit create fork. Give it a second here. Let's see if we refresh. Yeah, so now once you're on this page, you should be on your fork. Hit the big green code button, click code spaces, and then click create code space on main, and let GitHub do its thing. It will take a second to set up, but this should be where you're at. And you'll notice actually you basically get a copy of VS Code in your browser. This is really cool. We'll talk about this in detail in a second here. But for the time being, yeah, just let it go through its thing. You'll see some files here once it's done. All right. Is anyone still going here? Is everyone in? Can you see the files? Okay, I'm not seeing any hands, so I'll assume that means everyone's at a working place on code spaces. Okay, cool. So yeah, quick overview of what code spaces is. What you just did is actually you loaded up, and there's a dev container pre-made for this project. You can actually see in the dev container here. But instead of having to have to run that locally with Docker, GitHub provides this really useful service called Code Spaces, which is basically a fully featured browser-based development environment. So you'll see this basically looks just like VS Code because it is mostly just the code from VS Code. But now it's running entirely in our browser on this URL here on GitHub servers. Really convenient if you ever don't want to download a repository and set it up locally. That code space feature is available and everything on GitHub. And for our purposes, that's just so everyone is not constrained by the speed of the Wi-Fi here. But yeah, so something, we'll start off by just looking at, if we come down here to ports, if everyone has this little thing down here that says ports. And actually, I'll zoom in here. Yeah, this should be better. Cool, so you might be in the terminal, you might be in output or something, but if you just come over here to ports, it has a little blue 1 next to it. And you'll see this here. If you mouse over this address and click the little globe button, that'll open it in browser. And you'll get this temporary screen here. Just give it a second. And here we go. So what this is doing right now is by default, this code space is providing our index.html file, which is just our main web page here. It's providing it at this URL so you can see sort of what's happening. And what we'll notice is this is a really basic website. It's not meant to look nice, but it just says, hello world. This is a really cool site. And if you go to the bottom left here, you'll notice a little footer that says this page was last built at, and then current time here. So right now, that's not populated with the time. And if we go back to our code space, so everyone's here, open the index.html file. If we go into that, we can see, you can ignore most of this top stuff, that's just formatting for the page. But here, we have the text that says hello world, we have the text that says this is a really cool site, and then we have the text that says this page was last built at current time here. So is everyone good at this spot? Awesome. And so what we'll notice is right now, this current time here, it doesn't get populated, right? There's no sort of way of just automatically setting this right now because this is HTML. We can't do that. So to change that, we actually have a separate file here called build.py. So if you go ahead and open that up, it's a little Python program here. There's some sort of weird little things going on here, but at a high level, what this is doing is it's just reading in the file. So this is the only function that gets run in here, and it reads the file. So it opens index.html in read mode and reads it all into this variable called file data. So file data is now going to contain the entirety of basically the text. All of this text is now being stored in this variable called file data. And then we're setting another variable, current time, to basically the current date time. And this is just getting it for the East Coast. And then what we're going to do, this is sort of the key build step here. So this is, like I said, a custom build script, right? This could be whatever we want it to do, however we want to transform the code. In this case, all it's going to do is it's going to take file data, which is, remember, just the contents of index.html. And it's going to replace every instance of the string current time here with the string that is the current time variable. So what we just calculated, the current time, it's going to replace current time here with that everywhere in index.html, which means that at the bottom here, this current time here should be replaced with whatever the current time is when we run the build.py script. And then all we do from there is we don't want to overwrite the original index.html. So instead, we make a directory that's called out. So it's going to make a folder. You'll see one appear here called out. And then it's just going to write index.html to that path, out/index.html. And so if we want to go ahead and run this, we can open up the terminal to see what's going to happen here. And you might have something like this. Don't worry, don't close that. Just go ahead here to the top right, and you can see the little new terminal button. Go ahead and hit that, and we'll get a nice usable terminal right here. Is everyone in the terminal? Everyone good? Cool. So from here, we can just go ahead and run Python. We want to run our build.py script. So if you remember, the way we do that is we call Python, followed by the name of the script we want to run. So Python build.py. You go ahead and just run that. It should complete really quickly. It's not a very long program at all. Is everyone able to run that so far? Yeah, sorry. Ajay. Cool. So from there, now we'll notice there's a new directory called out right here, right? And if we go into out, we see there's an index.html file. If we open this up, and now we scroll down, we see, look, the contents of that variable has changed to basically this long date string, but it's the current time right now. It's in military time, but 3:01. And so that's what we wanted. And actually, if we want to view this too, we can once again go back to our tab that had hello world, our original index.html. If you lost this, keep in mind you can get to it again by going to ports, mousing over the link, clicking the web button. It'll load us back up here. And we'll notice, right, this still says this page was built at current time here. That's because the file that we're still accessing is, is this original index.html on our top level. We want to access out/index.html. So we can actually just change the URL to that. If we click on that, and at the end of our URL, we just add out/index.html, the path to our file. And we hit enter. Now we're going to load the new version, and we can see it has a date time at the bottom here. So to get there, keep in mind, we'll do this one more time. You come here, you go to ports, click the web icon, click the URL, and at the end of it, just append why is it not showing me that? out/index.html. Well, it didn't show up, but that's how we get there. And so you should be able to see this built version of the file. And so that's really nice. But the idea, right, with all this is to automate this build process. Right now, we're going to have to manually run, if we have our thing just as is, we have to manually run Python build.py and then upload this file to wherever we want. So it'd be really nice if we could just have it so that every time we make a change on GitHub, it automatically reruns, it automatically rebuilds, so we have the latest build time, and then uploads this web page to GitHub Pages. So that's what we're going to go ahead and do here. Give me 1 second so I can open up on my other screen here. Okay, cool. So remember, the way we're going to do this is with GitHub Actions. And GitHub Actions actually are very easy to get started with. The way we do it, if we all come back to our main workspace here, our code space, you go ahead and close out all the files that are there. We won't need those right now. What we could do is create basically a new folder. The way GitHub knows what actions you want to run is by specifying them in a special folder here called .github. So you can see you should be able to just right-click and new folder if you want, but create one called .github in the highest level. And then inside of this folder, go ahead, right-click it again, new folder, and create one called workflows. Oops, okay, workflows. And it should appear like that, sort of stacked on top of each other, but we have now this folder called .github, and inside of that we have a folder called workflows. And this is the path that GitHub, every time you push code, is going to basically search for to find what actions it should run. And the way we do that is with one more file now. Inside of workflows, we create a new file. And for the sake of this, we'll call it actions or action.yml. And you can install that if you want. You actually aren't really going to need it. So, I mean, I'll go ahead and install it here, but we're not going to really use it that much. And actually, if you do install it, you can just get back to the files by clicking the file button up here, get back to where we were. Okay, and this, okay, yeah, actually don't install it. Don't sign into GitHub. That's not necessary. Okay, so now we're here on action.yml. And has anyone here seen a YML file before?
Sorry,
Yeah.
I wanted to ask, is
Yeah.
the action one, is that a file or another folder?
Oh, it's a file. Sorry, I didn't specify. Yes. Inside of workflows, make sure when you right-click new file, not new folder. Action.yml should be a file. And what YML stands for, it's actually, sometimes you'll see YAML, they're the same thing. It stands for yet another markup language, which was just like a joke. They're like, okay, we have another file format now. But the way it works is it's a markup language, just meaning it's sort of just a simple way of describing some sort of little bits of data. If you think of Markdown, right, that's a way of easily describing how you should display text. Here, YML, we're going to use it for specifying what actions should be run. And so the syntax might seem a little weird, but just follow along, and you should be able to get a rough hang of it right through this. So the first thing we want to start with in our action is we want to specify what's going to trigger this. So for us, we're going to want to build every time we get a push. And luckily, GitHub Actions has a very convenient thing. If we just do on, colon, and then push. What that does is it tells GitHub, okay, run this action only when we get pushes. Why is it underlining this? Maybe, okay, well, if it's underlining it, don't worry, we'll get to that. And remember, so if we go back here, the way that our whole workflow is structured, right, is we have a workflow, it's comprised of jobs, which are comprised of actions or scripts. So we're in our workflow. Now we need to specify our jobs. And the way we do that is with this handy key that's just called jobs. So if you go ahead and do that, you'll get, now we're in the jobs section. This is where we can specify exactly what we want GitHub to run. And now in here, if you hit enter, use enter because actually YML is like white space sensitive, meaning that tabs sort of matter. If I untab here and type something, it's not going to be right. So make sure you can just hit enter from there. It should automatically do it, or tab out. But make sure you're at this point. And now what we could do is we could specify our jobs that we want to run. So this first one we're going to call build, right? Our first step here, if we're thinking about how we want to transform this file, first we're going to want to do this Python build.py script. So we just specify it. At this point, whatever you specify here is just a name. So we could call this like my build if we wanted to, for the sake of simplicity. We'll just call it build. And make sure tab out. So now we're under jobs, under build. And now we specify a few things. So we'll begin with the steps. And steps basically here are saying, okay, so we have our job, we have the name of the job. Now, what steps do we want to take? And the step is basically an action or a script. So under steps, we can specify the way you have to do this is you do a dash, space, and then name. So if you go ahead and do that, and colon, we can call this step whatever we want. So the first step here for us is going to be checking out the repo. And what that means, right, if you remember, it's sort of basically cloning the repository, basically getting our code so that we can work with it. So we can call this whatever we'd like. For the sake of this, we'll call it checkout repo. And sorry, a quick word. If you're not following along, that's okay. This is like, it's very foreign when you first see it. Really just make sure you're typing the same thing so that we can get to the same spot and you don't. And you sort of are able to run it and see how it all works. And so now we're going to do jobs, build, steps, name, and we're going to want to do uses, and for this one we're going to do actions/checkout at v4. And let me double check here. Okay, well, we'll get to that. Sorry, you'll notice something here. It's kind of weird. I did dash space and then I did 2 spaces out for uses. Like I said, YML or YAML is white space sensitive, so you actually do need to align these. It's really weird, but just make sure that name and uses are aligned at the same sort of spacing out. And now we can go ahead and do, again, so at this point, the first step that's going to be taken is our repo is going to be checked out. So now we have a copy of our code to work with. So now our next one is going to be the actual build step, right? We're going to want to run python build.py. So this one, we can just call it whatever we want. We're going to say build index.html file. This is just a name. This doesn't really matter too much. Space out. And we do, in this case, instead of uses, right? Uses is when we have a GitHub action that we want to run that's predefined. But when we have a script that we want to run, we use run instead. So run. And we just give it the script that we want to run. Build.py. All right, and if you have these red squigglies, don't worry, that's still normal here. And so at this point, we will have on our GitHub action, we will have a copy of our code. We'll have run build or build.py. So we're now going to have this out file with index.html. And the last stage here, remember this is sort of a GitHub specific stage because we're going to be deploying this website to a GitHub URL. But this is just going to be basically an upload stage. So name, we can call this upload file, upload built files. And once again, space out. And this one is going to be uses because it's a pre-made action for us. We'll do actions / and this one is a little long, but upload -pages -artifact at v3. And you might be thinking, like, okay, so these are what are these actions exactly doing? Like, how do I know what exists here? If we actually just sort of, I'll command click. You don't have to do this, but I think this works if you install the extension there. These are actually all specified on GitHub. These actions are themselves GitHub repositories, and we can actually view it on the marketplace. So this is where you can come to search for any action that you want. This is one made by GitHub called checkout. And this one just checks out your repository, right? Very simple. But this is sort of how you can know what exists, sort of find one that fits your purposes. That's just how you find those. And so you can tell, because it says uses and then some sort of path, that's a pre-made action, whereas run is going to be a script that we run or specify locally here. And this is actually going to require one more argument here, where we do with. And this is basically a way to pass this action some data, because this upload pages artifact is going to say, okay, what files should I upload? It doesn't know yet. So we could just pass it this. You do with colon, and then enter, and then path colon, and we give it a path like out. So this is our out file right here, and this is telling us, okay, take this out file and upload that. That's what we want to upload. And so I'll pause here for a second in case anyone's falling behind or something, but make sure your thing is formatted the same way, where name and uses are sort of tabbed out to the same length, and here name uses with, and then spaced out 2 more spaces more is path. Okay, cool. And you'll see this whole thing is has a red underline. If we mouse over, it says missing property runs on. So if you keep in mind what GitHub Actions actually are, right? It's just taking our code, it's taking whatever we specify, and it's running it somewhere. It's taking these actions, it's running them, it's running our Python script. So we actually have to tell it, where do we want to run this? And so there's a lot of ways you could do this, but a really simple one, if we just come up here between builds and steps, so just hit enter, and we do runs-on, we tell it, okay, this is where we want to run. And for the sake of this, type this, Ubuntu-latest. So that might not mean anything to you. What this actually is Ubuntu is just a certain distribution, a certain type of operating system that uses Linux. But it's just telling it, just take a machine that uses Ubuntu, the latest version, and just use one of those machines that you have lying around to run this code. So there's a lot of options. We could tell it to run it on Mac OS. If we had some specific Mac OS build scripts, we could tell it to run on Windows as well. For the sake of this example, we're just going to use Ubuntu latest. You really don't need to know that in depth. That's just, we need to give it somewhere to run our code. So, is everyone, sorry. Yeah.
On the server, or
Yeah.
where is it?
Okay, great question. Yeah, so this is basically specifying a server, a remote location to run our code. We're not giving it the exact address of the server because we don't care exactly where that server is. We're just saying some server that runs Ubuntu. Now run our stuff. So yeah, let me be very clear. This is not happening on our computer. This is specifically happening on some server that has the Ubuntu operating system. It could be a server, if we wanted to, that has the Windows operating system, or a server that has Mac OS. But yeah, does that make sense? Is anyone behind on this? Is everyone good for me to move on? Okay, cool. So if we come back here, let's go back to our little plan here of what we're gonna do. So we're gonna use a custom Python script to build our code. That part is done. We've just completed the build step. If this gets run now, we get this nice little, we run our Python script and it gets uploaded, all the files that are in our out directory get uploaded. So now past that, what we're gonna wanna do is now actually deploy it to GitHub Pages. And so what you'll see here is we can now, that's gonna be a second job, right? We said we're gonna have 2 jobs. And to do that, we just come down here, hit enter a few times, and actually backspace until your cursor is flush with build. So if we do anything that's tabbed out more, it's gonna actually consider it to be under like build or another step, but we don't want it to be part of that. We want to have a new job. So make sure your cursor is all the way back here. And now we'll title this job. Once again, we can call it whatever we want. For the sake of this, we'll call it deploy. And hit enter. And the same deal is going to apply here. We're going to have steps. And for this one, we could do -name. And this one we'll just call deploy to GitHub Pages. And we'll also uses, right? So this is going to use another action, just like above. We used upload pages artifact, upload check or actions checkout. This one is going to use actions / deploy -pages at v4. And what this is going to do is essentially take the file that we just uploaded and now make it accessible at a link that we want. Yes.
Why did you not put the keyword action in front of it like the other ones?
Sorry.
Wait, did I do that wrong?
So.
I thought before you had put like actions and then space and then the rest of the stuff, but I guess I just.
Oh no, yeah. Make sure it should be uses : space, and then this whole string here, actions / whatever action we want.
Sorry.
No, you're good. Great. Does everyone have that? Cool. And so once again, right, it's going to get mad at us because we don't have this. We need to tell it, once again, runs on. Where do we want to run our code? What type of server do we want to use? And in this case, we can do the exact same thing. So come up to deploy, just hit enter there, and we once again give it runs on. We'll tell it Ubuntu-latest, which just means find a server that's running Ubuntu and run this these actions there. And this next step here is going to be a little convoluted, a little bit much to type. So actually what we'll do is I'll type it out here, and then I'll also sort of copy it to a GitHub announcement so you guys can copy it in there, make sure you have this right thing. But what this relies on, right? So right now it doesn't actually know what it should upload. It doesn't know sort of where to upload it. There's some extra data that we have to specify for it. And actually we can see that if we go to deploy pages, We view on marketplace once again. We see it's actually giving us sort of documentation here on exactly what we need to run, what we need to include in our YML file to run this effectively. There's a lot there, so well, I'll go ahead and I'll just type that out here. But we're gonna need one more thing. So we can come up to runs on, we can enter in here. And we also need to specify environment. And this is basically, if you remember, environment variables from your from the original sort of command line activities. This is sort of what we're. This is the exact same thing, where we're specifying some environment variables for the action to use. And for here, we're going to have one called name. That's GitHub-pages. And then we also want the URL that we want to deploy to. And this is the really convoluted part. It's $. And don't worry, if you can't type this, I'll send this out in an announcement in a second here. It's basically this, steps.deployment.outputs.page_URL. So that's, I know, very verbose, very annoying to type. Once again, if you can't type that, don't worry. We'll come back to that. Yeah, question?
Does this name need a dash in front of it as well?
Oh, good question. So you're asking, like, with name here there's a dash and with this one there's not. So that's just some YAML specific stuff. What the dash actually denotes, I believe, is that it's sort of an entry in an array, whereas this is like, you can sort of think of this as like a dictionary with multiple levels. Sorry. It's very annoying, but no, in this case you don't need a dash in front of it. And past that, we are gonna have an enter again, backspace, so we're at the same level as environment. We need to specify, so this is a key step. This is something that you'll see in a lot of GitHub Actions, needs. So what needs says is, okay, this step is going to trigger, but we actually need something to happen before this. And what we actually provide here is the name of a previous job. So in this case, we'll provide the name build. And what this means is this needs build to complete properly, or else this is not gonna really be effective. So if build doesn't complete properly, don't even like bother running deploy, it's not gonna work. So sort of specifying we need build to run, and then we can run this. And then one final thing here, we'll do permissions. And this is just basically our way of telling GitHub what permissions should we give this action. And in our case, we're gonna wanna give it permission to write a page, and this special one called ID token, which once again is sort of a GitHub specific thing. And that's all to say, right, this is really, there's some parts in here that are kind of weird that are not immediately clear that you need to include. But that is sort of the point of these pages. If I go back to the documentation here for this this action, that's why these pages exist. These are sort of markdown files that include some good documentation on exactly what you need. So right, it needs the build job, the exact permissions that we just specified, the environment that we just specified, runs on, steps. These are all included here, and that's, those are what I used when I was putting this together last night. I didn't know this off the top of my head. For most actions, you probably won't know anything off the top of your head. You'll have to go and read sort of the documentation for them to figure out how to use them. But I don't know what that is. Okay, so up until now, if you followed along, hopefully you have this. If you haven't, I'm going to right now put out a little Canvas announcement with the code that you can just copy here, so that no one gets left behind. If you go to the announcement titled L13 link, I've just added a reply to it that is let's see, actually, sorry, 1 second here. Okay, here we go. Okay, there we go. I've just added a reply there where if you click on this now, you should see, I'll even open it here. Oh, sorry. Thanks.
Yep.
Okay, so if you come to this announcement here and just click this link, it's been pasted right here, you get this. If we just Command A or Control A on Windows, you can copy it. And I'm gonna do the same to make sure I didn't mistype anything. Come back here to action.yml and just delete what's there and paste in what I have there. So you can do this if you want to double check. It should be the exact same. Some of the things are a little out of order. I put like environment at the top, but it's the exact same stuff we just went over, just to make sure you have it right. And that's all we need. So now we've specified our build step, right? We're saying take a server that runs Ubuntu, and then run these steps in this order. So first, check out the repository. Remember to get our code from GitHub. Build the index.html file, so run our Python script, and then upload that out file, or out folder, the files that are in there, upload them. And then our deploy step is now taking in wherever we just basically wherever we just output these files to, it's taking those in, and now it has a single step that's deployed to GitHub Pages, and it just uses that action there. So what we could do, before we actually run this, we have to take one step to allow this, and that's actually if we go back to our original repository here, so wherever you, your fork is, where you click to create code space, come back here. And once you're here, go to the settings up there at the top. And on this page, come down to the Pages tab here on the left. Click that. And then here under Source, instead of Deploy from a branch, just click GitHub Actions. And you'll see some stuff change. Don't worry about that. Once again, if you do this, come back to your fork where you made your code space. Go to the Settings tab. Go to Pages on the left side. And then just change the source drop-down. Make sure it's make sure to select GitHub Actions. And what this allows is basically saying, okay, the GitHub page for this repository, allow GitHub Actions to override it. So is everyone there? Does anyone, just raise your hand if you need a bit more time. Okay, cool. Wait a second. Oh, okay. Sorry, yeah, you might get a weird icon for this by default. Some people are getting an exclamation point. Don't worry about that. As long as you have a folder called .github, a folder called workflows, and then a file inside of that called action.yml, it's okay. So it should, your code space should look exactly like this in terms of the sort of structure there. So, okay, cool. Anybody else need any help? Wants to double check something? Okay, awesome. So now we're ready to actually run this action. We put it all together. And now all that's required is we just, so there's a few ways of doing this, however you like committing your changes. There's a little UI here that's really nice to use in code spaces. We can also do it from the command line. For the sake of staying consistent with our earlier lessons, I'll do it from the command line. So I'm just going to first run clear here to get rid of this. And it also, once again, if you're sort of stuck on like this or something in your terminal, you just click the plus button up here in the top right, and you'll get a fresh terminal to work in. But first of all, I'll do git status to see what's up. And we see, yep, untracked files. So remember, nice little shorthand for that. If we just run git add period, that'll add all our untracked files. And if I run git status once more, okay, now it's green, it's ready to push that. So I'm going to run, I'm just going to clear my screen here. I'm going to now run git commit -m, write our message, and I'll say add GitHub action, close quote. So remember, this is just our command to make a single git commit. Go ahead and do that. Looks good. And now comes the fun part where we push it to Git, and this is what's actually going to trigger our workflow. So we do git push, this should work, origin main. If we just do git push origin main, remember we're saying git push to our remote, which is origin, to the main branch. Run that, and there we go. Looks good. And now if we hop back over to our fork and give this page a refresh, you can see something very cool here. So we just got this new commit, add GitHub action, the one that we just made, and we see this little dot next to it that says pending. So if we click on that, we get this detail about our actions, and we can actually hit the details button there. Another way to get here is if you're just on the repository, you can just click this actions tab at the top here. That'll take you straight to GitHub actions. And now we're here, and we can actually click on add GitHub action to see it running and its progress. And what you'll notice here, was everyone able to get to this step? Should I? I'll wait a second here in case. Yeah.
Back to the terminal.
Yeah, for sure. Yeah, so remember the 3 steps for sort of committing here. If you haven't done this already, you can run git status to see your files, git add period to add all your files, and then git commit -m, some message, and then remember once you've committed, git push origin main. And that should trigger your workflow. And yeah, we'll come around here to make sure that's okay. That's it. Okay. Okay. Quick question or a quick point, actually. If you're getting sort of a deployment error, so if you're looking at your action and for some reason build completes but deploy is red, what you likely need to do here is go to settings in the repository, come down to the pages tab on the left side, and then change this source dropdown. It might say branch right now. Change it to say GitHub Actions. Just click that. And that is the setting that you need to change. You can come back to Actions after that and click the one that just on your screen. It should probably have a red X if it errored out. Click on that, and you can hit rerun all jobs in the top right to sort of re-trigger that workflow, and then it hopefully will run successfully. Okay, quick announcement here. We only have 5 minutes left in class, so if you look at the grade scope, sorry, if you're still having issues, that's not a problem. We'll still go around here, but just hop on the grade scope for today, and there should be an attendance check, L13 attendance check. If you're still like having an issue with your deployment, there's a section that says submit a link for your GitHub Pages deployment here. Just put like having issues. We'll still go around here and help you guys out, but for the time being. And it says to do this in group, or the thought was to do it in groups, but you could do this solo on your own in groups if you want. Just come up with a little something for each problem. Doesn't have to be very long at all. But just thinking about the question on the grades. Oh, sorry, yeah. When it says the link for your GitHub page deployment, we mean this link right here. So if you go to the activity, you see it's run, and you click the link here. Okay. Sorry, quick announcement here. If for some reason your link is not showing up in the deploy job, you can go to settings and then go to pages. And assuming it all worked properly, you'll have the link right there. You can submit that for the grade scope activity. Sorry, wait, everyone, one final announcement real quick. There is a homework assignment with this. It should also be open on Gradescope. If not now, then after class in like a minute. But that assignment is building off of this activity in class today. So if it's still not working for you for some reason, I'll be here after, so you can come see me right now. Or this lecture, just follow along online and just try and get it to a working space, because that's what the assignment will rely on. Yeah. Due date is LDoc, yeah.
Yeah, so it's
Yep.
still mileage.
Yep, regular assignment.